Hi guys, welcome to the tutorial chapter 7.2 Direct Current. Okay, my name is Madam Azwani. Okay, previously we already discussed topic 7.1, okay, electric current. So today we will go to the new topic, okay, new tutorial which is 7.2 direct current. I hope that you already tried the question, okay, from this topic so that it's easy for you to understand and can help you to complete the answer for this tutorial. Okay, so first let's look the question for this topic. Okay, okay. I don't want to discuss all the question, all the problems. Okay, I will just have the question, which is I think that is difficult. Okay, to solve. Question one. Okay, you can refer to your notes. Next to question two, question three, and question four here. Okay, for question two, question three, question four, you need to solve. Okay, your question using the concept of the resistor. Okay, connected in series or in parallel. Okay, example for question two. Okay, they want you to calculate the voltage, okay, across each resistor. Okay, for this part, okay, you need to understand the concept. Okay, you need to know to differentiate between the voltage, how to calculate the voltage, okay, how to calculate your current, and how to calculate the total of your resistance in series or in parallel. Okay, so for voltage, okay, across each resistor for question 2 is not the same. The value of your voltage it depends on the resistance. Okay, for each resistor. How about the current? Okay, in the series connection, okay, the current must be the same across R1 here or across R2 here. So you need to understand, you need to know how to apply the condition, okay, the concept to your question and to your problem. It's same with question 3, okay, you have three resistors connect in series. What happened to the value of your current? The current must be the same. So next, you want to calculate the total of your resistance. The equivalent of your resistance, you need to apply the formula to calculate the total of your resistance in the series. Okay, rotation difference also same like question 2. Okay, you need to calculate one by one. V equal to IR. The I value must be the same. R is depend on the value of your resistance. Okay, is it for question 4? Okay, is uh series also. Okay, three resistors connected in series. Okay, you need to apply the same concept. Okay, next let's go to the question 5. Question 6. Okay, if you see question 5 here, okay, you have a combination of series and parallel. Here you have a series connection. Okay, 1 ohm, 2 ohm, and 3 ohm. Then connect with 3 ohm of the resistance of your resistor, okay, with a parallel, and then parallel again with this resistor. Okay, so the whole thing here, okay, connect in series with this resistor. So you need to calculate one by one. Okay, this goes same with question number 6. You have a mix of the connection. You have a parallel here, you have a parallel here, and connect with this resistor and also to this resistor. So you need to calculate one by one. So you need to remember the formula, how to calculate the resistor in series and how to calculate the total of your resistance in parallel. Okay, is it clear? Okay, let's go to the next question. Question 7. Okay, question 7, you have a parallel. So you need to apply the same concept, but now you have a parallel connection. Okay, your two resistors connect in parallel. So what happened to the current? For each resistor must be different. Okay, how about the voltage? The voltage value across each resistor must be the same. Okay, so remember that concept. Okay, then how to calculate power? You need to use using the formula of the power. Okay, next question 8. Okay, here for question 8, you have your internal resistance. Okay, so when you have your internal resistance, you need to consider the internal resistance in your calculation. Okay, so here, okay, your internal resistance equal to 3 ohm. Okay, so this is your internal resistance inside your battery. Okay, so you want to calculate the total of your resistance here of the circuit is referred to the external 6 ohm, 1 ohm, 5 ohm, and 4 ohm. Okay, so you have parallel and connect series and another resistance also series. Okay, so you need to calculate the total of the equivalent resistance of the circuit. It's referred to the external resistance. Okay, next, okay, if you have your internal resistance, you need to apply, okay, formula E equal to V, which refer to the terminal of your voltage, plus I R. Okay, R is the small r. Okay, V here is the equation is referred to the I, okay, R. Okay, I, okay, external R. Okay, so you want to calculate the terminal of your voltage here. Okay, so IR. By using Ohm's law, we need to calculate the total of your R and I in your circuit. Okay, and then find with the external resistance in your circuit. Okay, is it okay? So if you have your internal resistance, you need to consider in your calculation, then you need to use this formula. Okay, next, let's go to the new question. Okay. Question 10, question 11. So starting from question 10 and onward, okay, the problem is related to the Kirchhoff law, okay, or Kirchhoff rule, okay. So you need to remember that concept, okay. So you need to remember that concept, okay. Okay, you have Kirchhoff first law, okay. You have your Kirchhoff second law, okay. The equation for the first law, second equation for your second law, okay. And the most important thing is the direction, okay. So and also the sign convention for your EMF and also for the IR. Okay, so you need to draw the direction of the loop, the direction of your battery, the direction of your current. If your direction is wrong, is your sign convention for E wrong, the sign convention for IR also wrong, your calculation is wrong, and your final answer will be wrong. Okay, so the direction, the sign is very important. Okay, let's try the question. Okay, question 11. Okay, let's look how to solve the question, the problem. Okay, if you refer to this question, you don't have any junction. You don't have a junction. So no need to apply the first law. Okay, first law, you just apply the second law, the second rule. Okay, here first you need to draw the direction of your current. It's up to you. You can draw the direction of your current clockwise or anti-clockwise. Okay, then for the direction of your current, next the direction of your loop. Okay, here my direction, my current direction is clockwise, my loop direction also clockwise. Okay, next label your battery. Okay, now you have three battery, E1, E2, E3, and also don't forget to label your R, R1, R2, and R3. Okay, it can help you to reduce your mistake because sometimes you have a lot of battery, a lot of resistor in your circuit. Okay, next, apply second rule of the Kirchhoff rule. You have a total E equal to total IR. Okay, no need to consider or no need to apply first rule. Okay, you don't have any junction. Don't forget to draw the direction of your battery on each battery. Okay, so the direction of your battery always from positive to negative. Okay, let's write the equation. Okay, so E term in your left side, your IR term in your right side. Okay, so E1, why E1 positive? Because of E1 direction is the same with the loop direction. Next, E2, why your E2 is negative? Okay, let's look here. The direction of your E2, direction of your battery is going up. Okay, and then the loop direction is going down. Okay, so you have a negative sign. How about the E3? E3, the battery is going up direction, and then the loop direction also is going up. So you have a positive on your E3. Okay, next, equal to IR. So you have only one R. So IR1 plus IR2 plus IR3. Okay, all positive. Why? Because the current direction, okay, is the same with the loop direction. The current direction across R1, okay, the current direction across R2, the current direction across R3 is the same with the direction of your loop. Okay, substitute the value into your equation, your formula, and then calculate the final answer. Okay, so this is your final answer for this question. Okay, so next, let's another question. Okay, let's go to question 12. Okay, here, okay, calculate I1, I2, I3. Okay, you want to calculate the value of your I1, I2, and I3. Refer to your circuit here. Okay, you have a direction of the current at the junction, means you need to follow. Okay, so you have I1 entering the junction, you have I2 leaving the junction, you have I3 leaving the junction. Okay, the current direction done. Okay, next, the direction of your loop. Okay, you have loop 1 here, you have a loop 2. It's up to you. You can draw the direction of your loop clockwise or anti-clockwise. Okay, and then don't forget to draw the direction of your battery. On each battery here, you have E1, you have E2, you have 3. Label the battery and label the resistor. Here you have R1, you have R2, you have R3. Okay, next, apply the Kirchhoff law. Okay, so first you have your first law, total I in equal to total I out. Okay, so based on the current direction at the junction, I choose this junction. Also, you can choose this junction. Okay, so here I have I1 equal to I2 plus I3. Okay, I1 equal to I2 plus I3. So done for first equation. Okay, next equation, refer to the loop 1. Okay, based on the loop 1. Okay, I have E1 plus E2. So E1 is positive. Why your E1 is positive? Let's look here. The direction of your E1, the battery direction, okay, is the same with the direction of your loop 1. Okay, so your sign, okay, of your E1 must be positive. Okay, how about the E2? E2 also positive because of the direction of your battery E2 here to the right. Okay, and then the loop direction also going to the right. Okay, so you must write the positive sign for your E2 term here. Next, equal to I1, R1, you have I1. Okay, here you have R1, so positive. Okay, next, why positive? Okay, because of the current I1 across R1. Okay, you have a current flow here, I1. Here also, it's the same with the direction of your loop. Loop 1 here. So, you must write positive sign on your I1, R1. Okay, next we have I2. So, this is the current I2 direction across R2. Okay, so it's the same with the direction of your loop here. So, you have a positive. Okay, I2, R2. Okay, is it okay? Next, loop 2. Okay, so the equation based on your loop 2, you have E2 here. Okay, this is your E2. Okay, direction to the right. Okay, but your loop direction is going to the left. Okay, so you need to write. Okay, the sign of your E2 is negative. How about the E3? E3 is positive. The direction of your battery on E3 to the right here. Okay, how about the loop? Loop also going to the right. Okay, so that you have positive sign on your E3. Okay, next, equal to I2 R2. Okay, negative, why you have a negative here? Okay, let's look the direction of your current I2. So I2 direction is to the right. Okay, across R2 here. Okay, and how about the loop direction? The loop direction is going to the left. Okay, so you have the negative sign on your I2, R2 in opposite direction to each other. Okay, how about the I3, I3? So this is your I3. So I3 across R3. Okay, so this is R3, this is I3. Okay, compare with the loop direction. So this is the loop direction. Okay, this is your loop direction. Okay, with the same direction. So you have a positive sign on your I3, R3. Okay, is it okay or not, everyone? Okay, so you have your equation 1, you have equation 2, and you have an equation 3. Next, substitute the value into your equation. So this is your loop 1. Okay, this is your loop 2. Okay, loop 2 equation. Okay, so next, you need to substitute the equation 1. Where is your equation? Equation 1 is from the first rule here. Okay, I1 equal to I2 plus I3. Because why? You need to substitute. Why you need to substitute that the value of I1, okay, equal to I2 plus I3 into this equation, into equation 2, so that you have only two unknown. Because now if you refer back to question 2 and question 2 here, you have I1, you have I2, you have I3. Okay, so difficult for you to solve. So what you need to do is substitute the equation 1 into equation 2, so that you have only two unknown. Here I have I2, I3. Here also I2 and I3. So next, you need to solve your unknown value of your current by using the simultaneous equation. Okay, so here my working, I time with 5 here and time with 3 here, so that I have the same value for the I3. So I can cancel the I3 here. Okay, next I will calculate the I2. Okay, after that, after I got the value I2, okay, next substitute into any equation, equation 2 of equation 3, okay, equation 3, okay, equation 2 to calculate, okay, equation 3, okay, so that you can got the value of your I3, okay. And then use the equation 1. Using equation 1, you can get the answer for I1. So I1 here. Okay? So you can go to your answer scheme. You can check your answer with your answer scheme. Okay? For the I1, I2, and I3. Okay? Is it okay? Is it clear? Okay. Let's try. Okay? Or let's discuss another question. Okay? Related to the Kirchhoff law. Okay? Let's go. Okay. Can I go to question 13? Okay. For question 13. Okay. Again, okay, you need to repeat the same method, the same working, how to solve your question, your problem to calculate the I1, I2, I3 by using the concept of the Kirchhoff rule. Okay, first you need to draw the direction. Okay, the direction of the current at the junction. Okay, if you're given in your question, you just follow the direction of your current. Okay, on your circuit. So I have I in, I3 out, I2 out. Okay, and then the direction of your loop, loop 1. Okay, and then loop 2. The direction of your EMF. Okay, the direction of your EMF here. Okay, label, done. Okay, so next you need to write your equation. So this is your equation 1, total I in equal to total I out. So from your direction, from this direction on your circuit, I have I1 equal to I2 plus I3. Okay, next equation, next formula. Okay, E1 equal to I1 R1 plus I3 R2. Okay, so here, okay, E1 Y positive. Again, you need to see the direction of your battery, compare with the direction of your loop, same direction, that's why you have a positive. I1 R1. Okay, I1 R1 here, you have I1 across R1. Okay, compare with the loop, you have the same direction with the loop. Okay, I3. Okay, for this question, it's not necessary for you to write. Okay, I1 R1, then you need to write I2 R2. It depends on the current across on your resistor. Okay, if you refer to your circuit here, you have you have I3 here. Okay, across R2. So your equation in your second equation, okay, your first loop, on your first loop, I3 R2. Okay, so you have I3 R2. Next, your equation here, you can see in your loop 2, okay, equation for your loop 2, you have a negative E2. Why negative here? Because your E2 direction of your battery is to the left, and then your loop is to the right. It's going to the right. So you have a negative. This one, why negative? I3. So you have a I3 is going to the right. Okay, your loop is going to the left. That's why you have a negative. C. You have I3, R2 because I3 across R2. Next, you have I2. So this is your I2 across R3. So your term becomes I2 R3. Is it clear? Okay, so I2 R3. Okay, so next, repeat the same working, the same method like before this. Okay, substitute the value into your equation 2, into your equation 3. Okay, and then solve by using the simultaneous equation. But before that, don't forget to substitute the equation 1. So this is your equation 1. Substitute in any equation here. I substitute in equation 2. Okay, equation 2 here. So I have I2 plus I3, so become 8 I2 plus 8 I3. Okay, And then same working, same method, you need to repeat. Actually, you can use the calculator. Okay, you just press the calculator to calculate two unknown, like you want to calculate x and y in math. Okay, then you got the answer. Okay, so here I time with 3, I time with 2, so that I got the same value for I2 here. So I can cancel. Okay, then I got the I3 here, 0.54. Okay, next question. Okay, substitute the question. Okay, equation. Okay, I substitute the value of I3, okay, into the equation 3. Okay, I got value, okay, for current I2 is 0.03 ampere, and then last, okay, I got the answer for I1 using the first equation here. I1 equal to I2 plus I3. Okay, so this is my answer. I1 0.57, I2 0.03, okay, and I3 0.54. Okay, is it okay, everyone? Okay. I think I want to give, or I want to show another question. Okay. 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 Can I go to question 15? Okay. So you refer to your question, refer to your circuit. You don't have any direction of your current. Okay. But you want to calculate I1, I2, and I3. Means you have a three steps of your current. You want to calculate the value of your current I1, I2, and I3. So for this question, okay, it's up to you. Okay, the direction of your current at the junction. As long as you follow the first law. Okay, first of Kirchhoff first law. Okay, you have total I in equal to total I out. Okay, if you refer to my working here, to my direction of the current at the junction here, I have I1, I2, and I3. So I1 leaving the junction, I2 entering the junction, I3 leaving the junction. So my question, again, you need to repeat the same working, you need to repeat the same method. Okay, you need to apply first law of Kirchhoff rule. Okay, so I have I2 equal to I1 plus I3. Okay, next, okay, loop 1 and the loop 2. Again, don't forget to draw the direction of your battery, the direction of your loop, okay, on your circuit. Okay, so loop 1, okay, loop 2, okay, loop 1 you have E equal to I1 R1 minus I3 R4. So depend on your label also, okay. So I have E1 here, E1 going down direction, loop 1 direction also going down. That's why I have a positive sign for E1. Okay, I1 R1, I1 R1, this is I1, okay, across R1. Okay, minus, why minus? Because of my I3 is going down. My loop direction is going up here. So I have a negative sign for this term. Okay, I have a negative sign here. Okay, next E2. Okay, for loop 2 here. So E2, E2. Okay, so this is your E2. Okay, E2 equal to I3 R4. So same direction, the direction of your current I3 across R4, which is 3 ohm, is the same with the direction of your loop. Okay, the rest also positive because of the current across the current I2. Okay, across R2, across R3 is the same with the direction of your loop. Okay, that's why you got positive sign, you got a positive sign. Then done for your equation based on loop 1 and loop 2. Okay, next substitute your equation. Okay, next substitute your value into your equation. Then, okay, so repeat the same. Okay, repeat the same method. Okay, you need to solve for the I1, I2, and 3 again. Okay, you need to substitute the value here. So I have I2 equal to I1 plus I3. Substitute into the third equation here. 12 equal 3 I3. Okay, here. So that I got the new equation. The new value here. 12 equal to 9 I3 plus 6 I1. No more I2 in my equation here. So I have I3 I1. Okay, I have I3 I1 here. Okay, then solve. Okay, then solve for the I1 first. Okay, and then solve for the I2. Okay, and then solve for the I2. So I have I2, I3, and I1. Okay, for this question, okay, if you refer to this answer, I got the negative sign. Okay, I got the negative sign. Okay, for this I3. Okay, don't ignore the negative sign if you want to find another value. Let's say here, I would like to calculate the I2. So I2, by using the formula here, I2, okay, equal to I1 plus I3, okay. Consider the negative sign here. Okay, you need to bring your negative sign, okay, for the I3 in your calculation. Okay, to calculate the next value for the I2. Okay, so you can have your answer in terms of a negative sign. Okay, the negative sign it shows the direction. The value must be the same. Okay, is it okay or not? You understand or not? Okay, see, actually the process is the same. Okay, your working is the same. The method is the same. Okay, the direction must be correct. The direction must be clear. Okay, the rest part is math. Okay, I think that's all. Okay, for tutorial 7.2. Okay. Something. Okay, is it okay or not? Until this question, before end of this video, okay, I have for you. I think you got question problem for question 9. Okay, let's enjoy the video how to solve the question 9. You want to calculate the power on R3 here. So you need to apply the concept of the parallel and series connection. Okay, so let's go how to solve it. Okay, you have R2, 3 connect in series. So plus 3 plus 4, we got 7 ohm. And then connect with the R4 here. Okay, you have a parallel connection. So solve by using the formula for parallel connection. Okay, next. to find the total of your resistance in your circuit. Okay, so R equivalent, okay, the whole thing here connect in series with this R1. So you got 9.23 ohm. Second step, V equal to IR, okay, by using the Ohm's law to calculate the total of your current in your circuit here. Okay, so divide by the total of your R 9.23, you got 1.3 ampere. So you have 1.3 across R1. Okay, you have also 1.3 ampere across the whole thing here. Next, because of you want to calculate the power on your R3, okay, you calculate the value of your current, you calculate the current across the R3, but before that, okay, find the V, the voltage across R224. Okay, you have a current flow across the whole thing, and then the total of your resistance here. Okay, R3, R234. Okay, which is equal 3.23. Okay, and then you got the voltage value 4.2. Remember, okay, this is the parallel. Okay, R2, R3 connect with R4 is parallel. Okay, connected in parallel, so that you have the same value of your voltage across this line and across this R4, 4.2 and 4.2 here. So next, 4.2 of your voltage across V23. Calculate the value of your current across I2 and I3. The value of your current across R2 and across R3 must be the same because of R2 and R3 connect in series. Okay, so the value is equal to 0.6 ampere. So next, how to calculate power? Power is equal to I square R. You have a current across that 0.6 square times with the 4 equal to 1.44 volt. Okay, thank you.